We're starting today something a little bit different now. What we're starting is the correlation. And I'm going to start out on the whiteboard and then move into slides. And in order to do my initial demonstration, I'm going to gather some data from you and just write it on the whiteboard. I'm not going to do the actual calculations on here, but I'm going to plot it out and show you what this test means. And then take even a couple of little, and then we'll jump into some slides and go through it a little more systematically that way. We have a number of practice quizzes that'll help you with these concepts. And then it is kind of a long calculation process, just like you saw that it was for independent samples. That was kind of a long one, wasn't it? A lot of steps along the way. So let's just write up here what we're doing. So we're beginning with correlation. This is chapter 11, and this word relation and co becomes really important because when you're determining what test to use, you're usually looking for this word relationship. And that's because you're going to get paired data once again, meaning just like in chapter 7b, the paired samples t-test, you're going to have paired data. But here in this test, you're not looking to see whether there is a different score in these samples that's different from a different score in a standard distribution. Instead, you're looking to see if there is a relationship between the two variables. Or the two scores, however you want to look at it. So this is a way that you're going to have to distinguish if you're doing a paired samples t-test or a correlation, is you're looking for this word relationship generally. And in our problems that we use for class, I'll always include that word relationship because that'll help you. But if you were looking for it in actual research study, it might not state it so explicitly. It might say they're looking to see if these two variables were related. We'll put that word there too. Okay. And so we can't draw a causal conclusion here. When we do this study, we'll see why. You're only looking to see if one variable increases, does the other decrease? And so in order to make sense of that, let's gather some data right from the class. Okay, and I'm going to gather from each person 2 sets of data points. This is often how the data are gathered. So I gather person 1. And what I'm going to ask you to do is to put into the chat 2 pieces of information. I'm just going to speak it instead of writing it so I don't get the slide all cluttered. But I'd like to ask, since I already talked about sleep, I'd like you to assess right now, first off, write a number down that corresponds with the number of hours of sleep last night. And you're going to be putting this into the chat. So let me just say, write it in parentheses like this. And the first number corresponds to the number of hours of sleep last night. And regretfully for me, I think this wasn't very much. I don't really know when I actually fall asleep, but probably like 4. So write down your numbers. Don't give me like 0.875. Just give me like a whole number or maybe a whole with a half number, 6.5, something like that. Okay, that's your first number. Second number, write down your mood right now on a scale of 1 to 10. And let's just say like just overall how good you're feeling. So 10 is you're feeling just great. You're ready to charge into your day and face your day. And 0 is you're just feeling awful. You wish you were still, home in bed. You're just not feeling energy for your day. You're kind of down. And I'm going to put mine, despite my low sleep, I'm going to put it at a 6. I'm not feeling that bad, except feeling bad for being late to class. So I feel okay starting my day. Write those 2 numbers down, put them in parentheses, and put them into the chat. put two numbers into one set of parentheses, so it's easier. In the classroom here, I'm just going to ask you. So, Alexia, what are you two numbers? All right. And Keith? And Sequoia? Okay. And now I'm going to look on the chat to get the rest of these, or if I don't see them in the chat, let's see here. Okay, I've got a 9 and an 8. I've got a 10 and a 6. I've got a 4 and a 6 and a 5 and a 6. So a lot of times when you're gathering data, you'll see these are coordinates. And we're going to plot these out and see if we come up with any patterns, because that's what we're looking for. So correlation data are always displayed in a scatter plot, and that is the best way to know your data, is by looking at it. So when you work this week, you'll be creating a scatter plot. A scatter plot works on two axes. The y-axis, you guys know all this, I'm sure, but it never hurts to have a review. The y-axis is always your vertical axis, and the x-axis is your horizontal axis. I see that typically you put the predictor variable, which is sleep. So this loose hypothesis is that there's a relationship between sleep and mood. But since the sleep precedes the mood, in this way we're thinking about it, we're going to put sleep on the x-axis. I'm going to move this down here so I have a little room to write. And on the y-axis, we're going to put mood. Now, let me ask you a question. What do you think is going to happen? Like, would you expect that as the hours of sleep increased, that mood would also increase? Or would you expect the reverse of that? As the numbers of sleep increases, a person's mood would get worse. Which would you expect? As sleep increases, would mood improve? Or would mood get worse? Go ahead, Sequoia. Okay, you'd think that as sleep increases, a person's mood would improve, right? That makes sense, doesn't it, guys? Right? So we would expect that as sleep, where to write here? As sleep increases, mood would increase. So that's a prediction we have. We're going to call that a positive relationship, just meaning that we'd expect that as one increases, the other would increase. Now, the way we're going to create our little plot here is we're going to, on the sleep axis, we're going to kind of make it range from the lowest number, which is what I see is a 4, up to the highest number, which I see is a 10, and kind of squeeze them in the middle. Did I not just write a 4 here? I thought I wrote a 4 there, and maybe I didn't. All right, so let's see, 6, 8, 10. So I can divide it something like this with a 6. I'll put a little line there. And the 8. And then we have our 10. We'll do the same on the mood axis. And I see we're all ranging between 4 and 8. I'm happy for you, the 8 person. That's terrific. So we can just go 4, 5, try and make these evenly spaced, 6, 7, and 8. Typically, if one line is going to be longer than the other, we make the y-axis a little bit longer. The x-axis a little longer. That's typically how it's done. Now we're just going to plot these points, so you can go ahead and do it with me. The first person has a 4 on the x-axis and a 6 here, so their point is going to go right here. The next person has an 8 and a 5. The next person has a 6 and a 4. Next, we have a 6 and a 6. I hope you can see pretty evidently how I'm just finding the common point where these would intersect if we drew straight lines. We have a 9, which is going to be right about here, and an 8. We have a 10 and a 6. We have a 4 and a 6. It's another one right here. And a 5 and a 6 right here. Now, right now, we really don't have enough data points. In order to actually do a correlation, we would need to have 30 points. That's because we have to meet certain assumptions in our data. We have to be able to assume that our data are normally distributed. That is, if we plotted all these on a histogram, they would form a normal curve. That's for both sleep and mood. And there's a couple assumptions like that that are better met with larger samples. So we can't draw strong conclusions here yet, but I will ask you this question. If we were going to draw a line, I'm going to get a different pen color here. If we were to draw a line that was closest to the greatest number of points, where do you think that, would this line go like, I need to draw a straight line that's going to go like closest to the greatest number of points. These two up here are pulling it in this direction. I'd almost say our line is going in an upward direction. Something like that, maybe. Just doing my best to draw this line. And this is called our line of best fit. Because this line is in an upward direction, we would say that this is a positive relationship. And that just means that what we wrote right here, as one variable increases, the other increases. I'll write all those definitions down when we get to the slide. Positive in this context, though, does not mean good or bad. It has nothing to do with that. All it means is that these two variables are both increasing, okay? So when we're looking at actually measuring or examining this kind of relationship, we're looking at two different dimensions. So the first dimension, I'm going to erase this word just so I have room to write something on top of this. We draw our line of best fit, and then we can look at different color here. I'll get black out here. We can look at the direction of the relationship. And we can tell whether it is positive. And I'm just going to draw these two arrows, meaning that as one variable increases, the other variable increases. We can also tell because the arrow, though the line of best fit, goes in an upward direction. We might, in some cases, have a negative relationship, which in this context does not mean bad. It just means as one variable increases, the other decreases. And so, let's see, we might have hours of sleep increasing, and what might decrease as hours of sleep increase? Maybe stress level would decrease as hours of sleep increases. Does that make sense? As you get more sleep, is it possible your stress level would decline? Your anxiety might decline. Sleep helps with that. That would be a negative direction. We could tell because the line of best fit would go in a downward direction. Sometimes we can't tell, like there's just a bunch of random points on that line, and we can't even tell if the line should go up or down. And in that case, we just say there's nothing going on there. It's called a zero relationship. So that is dimension one that we can assess a relationship in the correlation. We also have another dimension that we can assess, and it is the strength of the relationship. And the strength of the relationship is telling us about how far are these points away from the line of best fit. So if we were to take this line and sort of calculate some sort of figure that indicated how far that point is, how far this point is, how far this point is, and this one, and this one, and this one, and this one. And we could figure out some sort of figure that captured that information. Then we would end up having an indication of the strength, and the strength is indicated on a scale from 0, meaning these points are just forming a big cluster and we can't tell anything about them. And the very strongest we could get, we take that 0 and put it there, the very strongest we could get is a 1. In a 1, every single point would be exactly on that line. And so in an example like this, so what's the number that comes right in the middle of 0 and 1? 0.5. 0.5 would be considered a moderate relationship. If that rings a bell, it should, because remember 0.5, that's how we rated a moderate effect size, isn't it? It's the same thing here. We're going to call a moderate relationship a 0.5. It's the number right in the middle. What's a number, actually, you can remember from our effect size, or else what's a number that would be kind of right in the middle of this? It's not exactly in the middle, but what kind of numbers come between the 0.5 and the 1? Any number that you can think of.
2.5.
Okay, and this is where we sometimes get into trouble. Remember, the maximum we can have is the number 1. That's the biggest we can get. So maybe I misheard you. Let me make that a better looking one. Maybe I misheard you, but if we had a 2.5, it would be way out here somewhere. We can't have a 2.5 in this kind of a situation. So because the very biggest number we can have a 1. So we're working with those decimals. If it helps you, you can think in your mind by just multiplying these times 100 and pretend that this is, let's pretend for a minute, let's pretend that this is 100. Let's pretend that this is 50. What would come in between? Yeah, a 7.5. And then if we put the decimal point in, we get a 0.75. So sometimes decimals, when you haven't worked with them in a long time, can be confusing. I recommend multiplying by 100. We're actually going to mark it not right exactly between, we're going to mark it at 0.8, because that is the kind of threshold for what we consider a strong relationship. And the number on this end, just like we rated in Cohen's effect size, to indicate a weak relationship is 0.2, and that indicates weak. And once again, if these decimals get you crazy initially when you're first working with them, get rid of the decimals, multiply times 100, think about it that way, and then slash it off in the end and divide it. So these are the thresholds for the strength of the relationship. The indicator for this relationship then is what we call the Pearson R value. And so we would say, if we knew, if we had done all the math, which we're not doing right now, we're just looking at these. If we had done all the math, we might say R equals, and maybe this is sort of a low to moderate relationship. So I might guess a number that's using the 0 to 100 thing, I might say this is a 40, but then I'll put that decimal point in there and say this is R equals 0.4. If it was a negative relationship, I would just put a negative sign in front of it, just like when we were doing the t-test. So I'm going to go through right here and give you some examples of, first off, let me ask if there's any questions right off the bat on this. Strength and direction. Okay, I'm going to give you some examples then. So first off, I suggested earlier that we might have a relationship between hours of sleep and stress level. So I'm going to gather those data now. We're going to do one more scatter plot and see what this one looks like. So now let's do strength. No, I just wrote down the word strength, intending to write down sleep. And we're going to measure sleep by stress. Okay. And once again, I think I had those 4 hours of sleep. And I think I am feeling a little bit stressed right now, especially because I was late, and lateness does increase a person's stress level. I'm going to put that at a 7. And let me gather data from more of you. You can put yours in the chat and I'll ask you in the classroom. So just give me your 2 numbers. Can I start with you, Lixia? All right, and Sequoia? All right, Keith? And I'm going to look online and see what we have here. We have a 6 and a 7, a 4 and a 10, a 9 and a 6, and a 6 and an 8, and a 10 and an 8. And I think that's all I see. Actually, I missed a 5 and an 8. Let me get that. I think I have everybody's. If you don't see yours up there, give a shout. But let's go ahead and draw another scatter plot. We'll draw our axes. Once again, because our sleep in this little loose hypothesis I'm forming preceded the stress, we'll put sleep again on the x-axis. And on the y-axis, we're going to put stress. The smallest score for sleep is again a 4, and the largest is 10. So we'll just evenly divide the remaining points in there. So it looks like we'll have a 6 about here and an 8 about here. And in the stress column, I see a 4 as the lowest point, and the highest point I have a 10. And so 5, 6, 7, 8, 5, 6, 7. No, I didn't space that evenly. I'm going to do it over just because I think I'll go by multiples of 2. 6, 8. We can fill these in if we want to. Okay, let's go ahead and plot these coordinates. The first person is the 4 and the 7. The second is the 8 and the 5. Third is 6 and the 4. And then we have a 6 and an 8. We have a 6 and a 7 coming up next. Is everyone very clear on how I'm plotting these points? You're familiar with this from earlier work? Okay. Did I get the 6, 8 and the 6, 7? I did. I should check these off. Next, we have the 4 and the 10 and the 9 with the 6 with the 8, another one right here, 10 and the 8, and the 5 and the 8. Okay. Now, in this example, we have a little bit trickier one. If you were just looking at it and you had to draw a line, would your line point in a downward direction or an upward direction? If we were to draw a line, would you point it in a downward direction or an upward direction?
Would it be upward?
All right. This one's really hard to tell. And the reason it's hard to tell is because we have what we call an outlier. This data point right here, I think is a little bit outlierish. It's not a great outlier, but it does kind of fall outside of the range. If we didn't have that point there, we could pretty clearly see a downward trend. Would you agree with that? That's fitting the closest if we didn't have this point. But we do, and that's a legitimate part of our data set. So if we're actually doing research, this is going to really reduce the strength of the correlation. So we always have to include it. I think that we'd almost have nothing going on if we have to accept that that is a legitimate point of our data set. Sometimes what we do in this situation as researchers is we investigate the sources of the data and we find out, is this person in some way very different from the rest of the people in our group, for any reason. And so if we find a reason, like maybe we find that this person, just came off, a week of work in the emergency room or something like that, and we say, okay, this is just not part of the normal distribution. For the sake of our example, guys, this is not something a researcher could do. I'm going to pretend the outlier isn't there and just fill in some more points just so we can see what a negative relationship might look like. So I'm just filling in some arbitrary points for the sake of the demonstration. So if we had a cluster of points, we had more students in here. This one right here is a little bit, outside of our pattern too. So let's imagine that we have this main pattern going on like this. So for the moment, for the example, we're ignoring the outliers. Does everyone understand that? We're ignoring those anomalous data points for the sake of the example. I'm going to write this down in case anyone takes a picture. For the sake of the example, we're ignoring outliers. Normally, we wouldn't do it. That wouldn't be appropriate unless we had a good, just reason. So now we know our two dimensions. We can assess the direction. And in this case, everyone answer, is it positive or negative? Okay. Let's just see some in the chat too, just to make sure this is clear, because this is going to be our very first practice quiz. Okay, good, good, good. It's negative. The line is going down. When we have a negative relationship, it's going to be indicated by a minus sign. When we look at our Pearson R value. The next thing we assess is the strength. And the strength of the relationship, once again, is the distance of, it's conceptually the distance of all these points from the line of best fit. How far is our data scattered around and scattered away from our line of best fit? And we assess it on a scale. I didn't make a good example there. On a scale from 0 to 1. And if those numbers, bug you when you're working with them, just multiply them times 100 and start with 0 to 100. That's easier to think of. In this example, if we don't think about the outliers, this is probably a moderate relationship. I would estimate, I'm going to put our estimate. I'm going to use this little approximately sign. Usually it's done with the equal sign underneath it, but since that's hard to get to in Excel without having to insert a symbol, we'll just use that top little, I don't even know what that's called. Does anyone know what that's called? I would say this is 0.5 for the strength. But when we write this down, we figure out the strength and direction separately. So the strength is here in the number. The direction is told with a sign. So we would have to put a minus sign here to show that it's going in a negative direction. So now we have an R score, a Pearson R value that we've estimated to be approximately 0.5. We would say there's a moderate relationship between sleep. This is it for your concluding statement, guys. It's super easy. If you get a correlation of 0.5, your concluding statement just says there appears to be a significant moderate relationship between sleep and stress. That's really easy concluding statement for this. This is really important, though, just remembering that. So let's imagine that in our first example, okay, let's imagine that when we had sleep by mood, let's imagine that the R was equal to 0.5. When we did sleep by stress, let's imagine that the R was equal to negative 0.5. The question is this. Which is stronger? Which is the stronger relationship? This one or this one? Anyone want to take a stab at that? It's a new concept, so you would just be guessing, and there's no shame in being wrong. Which would be stronger between these two? Okay, Anitra, good. Thank you for trying it. Okay. See a couple more. Okay, good to know. Anyone in the class want to hazard a guess? No shame. What'd you say? Okay, so here is how we have to think about it. A couple of you were on target with this. Remember, strength is indicated with a number. The sign just indicates direction. The two are like they're unrelated. They're measuring two separate dimensions. And so we're just asking you, what did I ask you? I asked you about strength. So all you look at is the number. 0.5 equals 0.5. These two relationships are equally strong. We ignore the sign. What if I asked you, we have two correlations. The first one, let's just put number 1, R equals negative 0.8. Correlation 2, R equals 0.5. And the question I ask you again is, which is stronger? Don't speak up and turn your chat toward me now. Direct it toward me if you haven't done so. And so now you have to tease out the difference between strength and direction when you look at these numbers. Which is stronger? Good one, huh? Okay, see some right, some wrong. Jelana, good. In the classroom, okay, good to know. In the classroom here, which is stronger? What are you thinking about this, Alexia? Okay, so now remember, this sign has nothing to do with strength. So for the moment, ignore it. Now, which is stronger? 0.8. So when you're figuring out which is stronger, you're always just comparing these two numbers without looking at the sign. The sign is important to tell you the direction, but it has nothing to do with strength. We'll do some more examples in a practice. So, by the way, I can save these whiteboards. If you find them beneficial, I can save them and post them for you. You can let me know if that's ever a beneficial thing. Now I'm going to show you what some of these might look like in terms of correlation. So first off, remember, you can't really detect very much. You typically want n to be greater than 30. We'll be doing examples smaller than that because we'll do at least one calculated by hand, but that's usually what you need. So let's look at all the possible relationships we can have. First off, we talked about, let's start with a strong relationship. In a strong relationship, all the points are pretty tight to the line. It might look something like this. This would be a strong positive relationship. And it might have an R around 0.8. Now, maybe this would be a 0.7, and we'd still say it's strong. Maybe it's a 0.9, we might say it's strong. You know, these are approximations. We could also have something like this. And in this example, we would call this still a strong relationship. Remember, strength and direction are separate, but in this case, it's a strong negative relationship. And the R might be negative 0.8, but they're still equally strong. We could have a weak relationship. In this case, we'd look at our data points and we would be able to see a line, but it might look, points are really pretty far away from this line. Might be a little bit hard to even tell what the direction is when you're trying to figure it out. Might look something like that. In fact, I'll make it even a little bit bigger. You might look at it and it's be like, well, it kind of looks like I can draw the line going up. I'm not totally sure, but I'm going to say that I can. Usually you have to be able to tell a direction. And in this case, we would call this a weak positive. Positive just indicating direction. And we might have an R approximately 0.2. And similarly, as you might guess, we could have a weak negative relationship. In this case, we detect a line going downward. And the points might be scattered, again, kind of far away from the line. You can still tell they're kind of going down, but they're pretty far away, something odd with it. And we might call this then a weak negative. And the R would be approximately negative 0.2. These are equally strong. The strength is equal. The direction is different. And we could have a moderate relationship. In something like this, the points you could definitely tell the direction, but they're not going to be close like these I'm drawing now. Some will be, but a lot more are going to be kind of farther apart from the line, something like that. I hope you can tell the difference in these. And this would be a moderate positive. And of course, we could have an equally strong relationship where the direction was the opposite. And this would be a moderate negative. And in this lower case, the R would be approximately negative 0.5. And in this one, the R would be approximately 0.5. There are two other kinds of relationships that we could have. First off, we could plot some points and we could have just nothing going on at all. Like we look at our data and there is just like, we don't even know where to draw the line. We can't even tell if it's positive or negative. Maybe the plots are forming almost where you could draw like an imaginary little circle around them. They kind of form a zero. And we call this a zero relationship. Let me get my red out here. I liked that. A zero relationship. And that doesn't mean that the R is exactly zero. You're almost never going to get that, but it would probably have a zero in the first decimal point. So it's going to be maybe it could be a 0.03, something like that. Or maybe it could be a negative 0.0, something like that. The sign wouldn't matter, but you just can't even detect a pattern in these points. I'll give you examples of variables that might form that relationship in a moment. Another kind of relationship you can have is a perfect relationship, just what I hope for all of you someday, but actually I don't because it's not achievable on this earth. I'm just joking. A perfect relationship just means that every single point is exactly on the line. And once again, after I draw the plot, I will give you an example. So here, 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 every point is precisely on the line. If you know what the point is for one variable, you know exactly what the point is for the other variable. And do any of you know what's the highest score you can get in a correlation? I gave it to you in the continuum. I said all the strength scores can range between 0 and 1. A perfect relationship looking like this would have, we'll call this perfect, and the R would be, oops, 1. The best you can be. We could have a perfect negative relationship. Doesn't mean bad, remember, just means the direction. And in this case, the line would go downward. Every point would be exactly on the line, but they're just going in a negative direction. And in this example, we would have R equals -1. So let's get some examples. Are there any questions right at this moment? I mean, that you just want to have cleared up right away because you feeling foggy at all? The only dumb question is the one that you don't ask. Meaning that if you don't ask it, you're not being wise because your questions are always good questions and they usually help your classmates. Anything in here that feels foggy so far? Okay, so let's take some examples of a perfect relationship. Perfect. So let's imagine that on one axis, on the y-axis, on the x-axis, let's start there, you have your height in inches. And on the y-axis, you have your height in centimeters. If I knew what your height was in inches, could I do a little calculation and figure out exactly what your height is in centimeters? Yes? Guys on Zoom? If I knew your height in inches, could I find out exactly your height in centimeters?
Yes.
So someone's here, you know, I won't even plug in actual numbers. We have someone here, we have someone here, we have someone here, we have someone here. Every single point is going to be exactly on the line. I can predict one point from the other point. It's a perfect relationship. Positive. So let me move this over and write that. Height in centimeters by height in inches. Perfect positive. Because as height in centimeters goes up, height in inches goes up. I'll put X and Y here. And I can perfectly know exactly height in centimeters if I know height in inches. An example of a perfect negative relationship. I think this semester we have 17 weeks in our semester. So on the bottom, I'm going to put 1 through 17. And so let's put that this is weeks completed in the semester. I think we're around week 12 after today's class for me, no, after tomorrow's class, I'll have completed my teaching at least for week 12. So let's assume I've completed week 12. We'll be optimistic and assume we'll get through this class and tomorrow. So let's say we've completed 12 weeks. If I know we've completed 12 weeks, can we know exactly how many weeks are remaining? Weeks completed. I'll write this here. By weeks remaining. I've completed 12, so let's give me a score. Person 1, we all have the same exactly, but person 1 has completed 12, and so I know I have 5 left because there's 17 in total. So I'll plot my point right about here. That's not a very good, but perfect example, but that's where it might be. Let's say this is a loose, we can all complete the semester at our own pace for whatever reason, and someone else has completed 10 weeks. How many weeks would they have remaining? If it's a 17-week semester. They'd have 7 weeks remaining. I know I'm not drawing the line very well. If someone's completed 1 week, how many weeks do they have remaining? Jennifer? Someone's completed 1 week? 16. They have 16 remaining. And if we were to draw this perfectly, we'd find out that as long as we knew how many weeks someone had completed, now I'm going to erase that and do it a little more neatly, we'd know exactly how many weeks they have remaining. So here would be the line. And we know every point would be right on the 9. If we know one, we could know the other. This is a perfect negative relationship. Just meaning that as X increases, as weeks completed increase, Y decreases, the weeks remaining decreases. All right. It is 10:05. Would you guys rather take like a 5-minute break now and jump into practice quizzes and stuff like that? And then have another break before we do the demo? Or do you want to have just one longer break in the middle? Cast your vote. Longer break in the middle or a break right now, a 5-minute right now and another 5-minute later?
Longer break.
All right, keep going. All right. Does she vote for everyone? Okay. All right. Way to go, Marlisa. So let's go into look at some practice. I'm going to go through these one at a time with you. I added some last night, which is always risky because it was the wee hours of the morning and there's a risk of mistakes when I do that. But I really wanted to get at these concepts independently. So we're going to go into practice 11A-1, I think it's called. I'm having trouble with my login, so it'll take me just a moment to log in, but do get into Canvas. Better pull that off the main screen, I guess. Right. I should be in here in a moment. Good morning, Yat A. It is good. Okay, this should let me in momentarily. Can't get in through my links at the moment because there's a conflict between my two computers. So we're going to go to the modules and then you can get into them through the practice quiz in module 11. I think also through this link on the left menu. I'll go in this way. And yes, looks good. Let's see here. I think there's one. Okay, don't go into this because let me get to a different one that I actually want you to take first. I added one yesterday, as I just mentioned, but it looks like I didn't link it because I was working really late, guys. So what we're going to do, first of all, is I think it's called, positive or negative. Really simple one. You guys are going to find this to be a real breeze. And take the quiz. And let me just link this up here. I don't know how else to get to it exactly. So let me just do this. And then while you're taking these first two, I'll go through and make sure the second one that I added is up here. Okay. Now this is going to be the easiest one. It's going to be as easy as degrees of freedom here. And I'm just going to save it. There we go. So go into this one. Once you clear it, you will probably have to refresh your screen. And all you're doing is indicating, I think I have positive, negative, or indeterminate. And so if you have one that you just can't see a direction at all, you can click that indeterminate. Otherwise, you're just looking at the direction. So once you refresh your screen, you should be able to see that. While you're doing that, I'm going to jump in here and add that other one that I created last night. Pretty easy, guys. Were you able to get in and just like, it's just like 1, 2, 3, I hope. Um, Everyone done? Okay, let's go in now. I wasn't sure what order to take them in, but right now I want to try this next one, number 3, guess the strength. Now remember, the strength is just how far the points are from the line, and I'm not sure how this will work. I gave you options of perfect, where every point's on the line, strong, where the points are tending to be close to the line, weak, where the points are kind of far away from the line, but you can still tell a direction, or 0, meaning you can't even tell what direction these points are going. So you can't assess, it's going to be like just a 0 relationship. So go ahead and do 11B2. Don't do 11A2 just yet. I want to go through some examples with you for that. (11B2). And if you do come across something that you think you're right and that the answer might be wrong, it is possible because these are brand new items I just made very late last night. When you're done, don't just do it once, do it, a couple times just to get the feel for it, because remember, your highest score is always going to be kept, and these are for practice, so it's beneficial to do them more than once. Do let me know if you find any that you think are too ambiguous to be included. I try to include only very clear examples. And people on Zoom, I think just take one more minute here and then don't open another one. Okay, you guys done? Okay. Next, we're going to go into predicting the strength, which is kind of a bad name for it. But all I'm wanting you to do is to get used to these norms. And they're the same norms that we used for effect size. But remember, if it has a negative sign in front of it, it doesn't matter, okay? So I think that all I have here is the, some numbers. Here we have R equals 0.15. So what could you say about this? It's moderate positive. Well, does this have to be positive or negative, guys? This R equals 0.15, positive or negative? It's got to be positive because we don't see a minus sign, right? Okay. Does this look closer? So remember our thresholds. I think I can write on here. Our thresholds for weak I thought maybe I could write on there, but I can't. So let me just pop up here again and write those thresholds. Write these down, everyone. So they're the same as the R the thresholds that we used for effect size. So weak are approximately 0.2. Often you're going to get 2 digits here, right? So look at that. So it could be like anywhere from 0.12, you know, up to maybe 0.3 or something like that, right? And it could also be, well, I put the 5 there, but let me erase that because 0.2 is the actual threshold. So 0.2 is the threshold for weak, and it doesn't matter. Thank you for your offering, ruler, if it is positive or negative. So we could also have our approximately negative 0.2 because strength has nothing to do with direction. If we have a moderate relationship, R is going to be approximately equal to 0.5 or R approximately equal to negative 0.5. And a strong relationship, R is going to be approximately equal to 0.8 or approximately equal to negative 0.8. Perfect. R is going to be equal to, notice there's no more approximately equal to here, 1 or equal to negative 1. And if you're looking at a 0 relationship, remember you're going to have a 0 probably in that first point after the decimal point. So we'll put a 0 here. We just call it a 0 relationship. It's not going to be exactly 0. R is going to be approximately 0.0 something or approximately negative 0.0 something. That's probably what you're looking for. And these are the norms for how we describe our relationship. And these are already familiar to you because of effect size. So jot these in your notes somewhere and then go ahead and take that next. Let's answer that first question together, actually. In this case, ooh, I like that last one. I'm going to talk about that. So first off, we have to rule out the negative one, right? So we know this isn't a negative relationship because there's no minus sign. So would we say it's a moderate positive using those thresholds I just gave you, or a weak positive?
Moderate.
Okay, now this is what you have to do because decimals mess people up. Imagine this is a scale of 0 to 100. And you've gotten rid of the decimal point and you have a 15. Is the 15 closer to 20 or closer to 50? It's closer to 20. Now get that decimal point back in your brain. And now what would you say? Is this a weak or a moderate? It's a weak relationship. Guys, work through the decimal place thing because it's going to throw you off. This last answer, the researcher made a mistake because our scores can't have that value. If you see there's no decimal, if it's greater than 1, it's an impossible. Correlations cannot be greater than 1. That's what that one's about. Let's just do one more together. The relationship between two variables had Pearson R value of R equals minus 0.88. What could be said about this? First off, is this a positive or negative relationship? Negative. We see our minus sign, right? It's little though. And so we know we have to rule out the other ones. Is it, what would you say the answer is going to be? It's a strong negative. We know it's not perfect because we'd have a score of exactly 1. We don't see a number greater than 1, you know, for the strength, so we know that this is possible. So go ahead and do some practice on this for, let's say, 4 minutes. If you need more time, you can ask, and let me grab my time. Set timer for 4 minutes.